Classes are a fundamental tool in any respectable programming language. Think of a class as a template for creating objects with related data and functions that do interesting things with that data. Python makes it easy to create and use classes. In fact, most other programming languages are quite jealous of Python for its elegance and simplicity. Today we will show you how to use classes in Python, and we will do so in a classy way. Suppose we are building a new social network called FriendFace, and our goal is to gather as much personal information as possible about our users, for reasons. We will have a lot of data about each user, and will write many functions using that data. To organize this effort, let's start by making a class called user. In Python, you define a class by first writing the class keyword followed by the name of the class. It's recommended that you capitalize all the words in the name of your class. Finally, type a colon and press enter. For our first example, we will make the simplest class possible. We will do absolutely nothing. Type pass and press enter. Pass is a way to type a line that does nothing. This is necessary because when defining a class, you need at least one line. Now that we have defined our class, we can use it to create different users. To make a user, type in the name of the class followed by parentheses. This looks like you are calling a method, and you are, in a fashion. We call user1 an instance of the user class. You can also call user1 an object. To attach data to this object, you first type the name of the object, a dot, the name of the variable, and then give it a value. Let's give user1 a first name and a last name. Since first name and last name are attached to an object, we call them fields. They store data specific to user1. To see that the data is in the user1 object, let's print them. You access the data the same way you assigned it. Type the name of the object, dot, then the name of the field. Let's also print the last name. Excellent. By the way, you should not capitalize the name of fields. And if you use more than one word in the field name, separate the words by underscores. This is a tradition in Python, so to avoid uncomfortable stares from your peers, I would recommend using this convention. Here, the name Dave Bowman is attached to the object user1. To make this clear, let's create standalone variables also called first name and last name. These values are not attached to a user object. If we print these values, we get the name Arthur Clark. But if you print the values attached to user1, you get Dave Bowman. Even though we use the same variable names, the values are kept separate. With classes, there is no limit to the number of objects you can make. Let's make a second user, called creatively user2. We will give this user the name Frank Poole. We use the exact same field names as before, but this time the values are attached to user2. To see that Python keeps these three names separate, we will print the three names. So classes are used to make objects, and each object can have different values for the same variable names. You can attach additional fields to the objects, and they do not have to be strings. Let's suppose user1 has an age of 37, an integer. And for user2, let's assign a value for his favorite book. We are now in a situation where user1 and user2 have different fields attached to them. The user1 has an age, user2 does not. User2 has a favorite book, but user1 does not. If you print the age for user1, you can see the value is there. And if you look at the type for age, it is indeed an integer. Now look what happens when we try to print the age for user2, which we have not assigned. We get an attribute error. So please, exercise caution. If you are not certain an object has a specific field, you may experience an error. I know what you are thinking. Why did we go through the trouble of creating a class when we could have just as easily stored the data in a dictionary? We will now see the additional features of classes, which allow them to transcend a simple dictionary. By adding methods, using object initialization, including help text, we can turn our simple class into a data powerhouse. The first feature we will add is an init method. A function inside a class is called a method. Init is short for initialization, and some languages call initialization methods constructors. The name of this method is init with double underscores before and after the method. This method is called every time you create a new instance of the class. The first argument to this method is the word self, which is a reference to the new object that is being created. You can add additional arguments after self. We'll add full name and birthday arguments. The first thing we will do is store these values to fields in the object. We do this by typing self, dot, the field name, and then assign it a value. We'll store the full name as a field called name, but we will store the value birthday in a field also called birthday. Be careful here. This birthday is the value provided when you create a user object, but this birthday is the field that stores the value. To keep this example simple, we will assume the birthday is in year, month, day format. We will now create a user and use the init method. Like before, you type in the name of the class and parentheses. This time, we must provide 2 values, because the init method is expecting 2 values. First the name, then the birthday. You can test that these values are stored in the object by printing them. The data is all there. Let's add another feature to our class. In the init method, let's break apart the name and extract the first and last names. We will call the split method on the full name and pass in a space. This will chop the name into pieces by cutting whenever it encounters a space. The pieces will be stored in an array. The first name will be the first string in the array, and the last name will be the last string in the array, which we can access using index -1. Notice that we attached the first name to self, but didn't do this with the last name. We'll see what happens as a result. Let's create the user just as before, and then print the full name, first name, last name, and birthday. Run. We get an attribute error when we try to print the last name. This is because we didn't attach last name to the object using self. What happened is we assigned the value to the variable last name, which only exists until the end of the method. This is a quick fix. Let's go back and attach last name to self. Now, if you run the code, everything works as expected. We can further improve this class by adding some help text. To do this, you type a special string which we call a docstring. This is a string inside triple quotes that you type right after the first line. Now look what happens when you call the help function for this class. Python displays a useful overview of the user class. It displays the docstring as a summary, and it also shows the arguments that are expected in the init method. Even if you are writing code only for yourself, it is a good habit to write a docstring. You may have to use a class years after you wrote it. A few seconds of typing is worth hours of sanity down the line. Also notice that the help call displays 2 additional items, dict and weakref. We will discuss these in the next video on classes. Let's add another method to the user class that will return the age of the user in years. Like the init method, the first argument is self. And to showcase our responsible nature, add a brief docstring. We will compute the age using the user's birthday, so this method does not require any additional parameters. Since we will be working with dates, we need to import the datetime module. Let's first get today's date. We shall assume it is May 12th, 2001, so that everyone who tests this code will get the same answer. Next, let's convert the birthday string into a date object. There is a way to do this in a single line, but for clarity, we will use a more direct method. In this example, we assumed the birthday was a string in year, month, day format. From this string, we can extract the year, the month, and the day as integers. With these 3 integers, we can create a date object for the user's birthday. If you compute the difference between today and the birthday, you get a time delta object. The time delta object has a field called days. Ignoring leap years, we can now compute the age in years by dividing by 365. Finally, return the age as an integer. To test this method, create the user once more. Then call the age method and print the result. 30 years old. Notice that you did not type self when calling the age method. The self keyword is only used when writing the method. By the way, if you call the help function once more, you will see the summary now includes a description of the age method. Classes are powerful contraptions. They empower you to group together data, which we call fields, and related functions, which we call methods, into a kind of factory for creating many objects, which we call instances. Socratica is somewhat like a class which creates instances of high-quality videos. Who sees our videos is determined by a mysterious black box called the YouTube algorithm. The best way to tell the YouTube algorithm that our videos are worthy of watches is to engage. Tell someone on FriendFace our video exists and that it's in a class